Welcome to David Alexander Maths Tuition. This is chapter 9c on the chain rule. Okay, so using the chain rule, can we differentiate y equals 2 plus 6x to the power of 5? Well, the answer is yes, we can. It's really easy. All you need to remember is the power comes down to the front, reduce the power by 1, and then differentiate what's inside the brackets. So power comes down to the front, reduce the power by 1, and then multiply by the derivative of 2 plus 6x, which is just 6. 5 times 6 is 30, so that's 30 lots of 2 plus 6x to the power of 4. Let's look at the next example. Power comes down to the front, reduce the power by 1, and multiply by the derivative of 6 take away 2x squared, which is minus 4x. So that can be minus 16x, lots of 6 minus 2x squared, all cubed. And the final example, power comes down to the front, reduce the power by 1, and multiply by, in this case, 2. And minus a half times 2 is minus 1, so that's simply minus 3 plus 2x to the power of minus 3 over 2. Fairly straightforward. Okay, let's have a look at this one here. So what we need to do is, when we're differentiating, we want powers. We don't have a power here, we don't have a power here, so let's turn them into powers. So y is 1 over 4 plus 2x. Well, that is the same as 4 plus 2x to the power of negative 1. So therefore dy by dx is going to be, power comes down to the front, minus 1, lots of 4 plus 2x, reduce the power by 1, the derivative of 4 plus 2x is 2, so that's going to be negative 2, lots of 4 plus 2x to the minus 2. The square root of 1 minus x we can write as 1 take away x to the power of 1/2. So therefore the derivative is going to be, power comes down to the front, reduce the power by 1. What is the derivative of 1 minus x? It's minus 1. So that's going to be minus 1/2, lots of 1 minus x to the minus 1/2. Done. Okay, this last example, nothing ridiculous going on here. Power comes down to the front, but when I bring the 3 down, well, it's obviously not going to turn it into a 63. It's going to be 6 times 3, so that's going to be 18 lots of 7 plus 6x squared, reduce the power by 1, and multiply by the derivative of 7 plus 6x squared, which is 12x. And we can tidy this up. What is 18 lots of 12x? Well, 18 times by 12 is 216. So that's 216x, lots of 7 plus 6x squared, all squared, and we're done. Okay, so here we've got a slightly tricky one with some trigonometry going on. So let's just follow the rules that we've been using so far. The power comes down to the front, the bracket stays the same. We reduce the power by 1, and then we multiply by the derivative of cos x. Now remember that the derivative of cos is negative sine, so that's going to be negative sine 2x, but multiplied by 2, so minus 2 sine 2x. Take away, now sine goes to cos, so that's cos of 3x times 3, so minus 3 cos 3x. So probably well, you can write it any way you want really, but I would probably write it as 7 lots of minus 2 sine 2x minus 3 cos 3x multiplied by cos 2x minus sine 3x to the power of 6. Okay, given that y is 1 over 3x take away 7 squared, what is the value of dy by dx where x is 0? Okay, so all we need to do is work out what dy by dx is first of all. What is the formula for dy by dx? Now first of all, I'm going to write this as y is 3x take away 7 to the negative 2. So dy by dx is going to be minus 2, power coming down to the front there, 3x take away 7, reduce the power by 1, and be careful, it's minus 3, not minus 1. Some people, when it's a negative power, add 1 instead of subtract 1. And we're going to multiply that by the derivative of 3x minus 7, which is 3. So therefore dy by dx is simply 6 lots of 3x take away 7 to the minus 3. Now if you want, you can write this as dy by dx. We can put it back into this form if you prefer that. So 6 over 3x minus 7 cubed. Now when x is 0, then dy by dx is 6 over 3 times 0 is 0 minus 7. So 6 over negative 7 cubed. So dy by dx is, what is 7 cubed? 7 times 7 times 7 is 343. So that's going to be, does it simplify? No, it doesn't. It's just going to be minus 6 over 343. So when x is 0 in this function, then the gradient of the curve is negative 6 over 343. Okay, so here is a harder example of the chain rule in operation. Okay, so you want to find the value of dy by dx at this particular point. So let's just work out what the formula is for dy by dx. So power comes down to the front, 3 over 2, multiplied by 3 plus the ln of 5x. The power reduces by 1, and we're multiplying by the derivative of 3 plus the ln of 5x. Remember that when you're differentiating a ln function, it's the derivative of the stuff over the stuff. So let me just put this to the side here. The ln of 5x becomes dy by dx is, this is the stuff here, so the denominator is 5x, the derivative of 5x is 5, so that's just 1 over x. So that is times by 1 over x. So therefore we can just simplify this a little bit by saying that that is 3 lots of 3 plus the ln of 5x to the power of 1/2 all over 2x. Okay, so we know, so when x equals 1/5 e squared, then dy by dx is 3 lots of 3 plus the ln of 5 times 1/5 e squared. Now 1/5 of 5 is 1, so that's just the ln of e squared to the power of 1/2 over 2/5 e squared. Now the ln of e squared, or the ln and the e cancel, so it will just be 2. The ln of e to the power of 5 is 5. The ln of e is 1. So the ln of e squared is 2. So therefore dy by dx is 3 lots of, so this happens quite a lot in questions. The lns and the e's make it seem incredibly difficult, but a lot of the time we can get rid of them when they're together. So that's 3 lots of 3 plus 2 to the power of 1/2 over 2/5 e squared. Now 3 plus 2 is of course 5, so that is 3 times the square root of 5, so I'll put 3 root 5 over 2/5 e squared. So we can tidy this up a little bit more so I'm going to write it as, let's just take it up here, so 3 root 5 divided by 2e squared over 5, so that is going to be 15 root 5 over 2e squared. So that is the value of dy by dx when x is 1/5 e squared. Okay, so here's another example. A curve has equation y equals 3 minus 2x to the power of 4. What is the equation of the tangent to the curve with x coordinate 2? Okay, so if we're talking about tangents, then we're probably going to use differentiation. So dy by dx is going to be power coming down to the front, 3 minus 2x, power reduces by 1, multiplied by negative 2. So dy by dx is negative 8 lots of 3 take away 2x cubed. Now when x is 2, then dy by dx is going to be negative 8 times 3 take away 2 times by 2, all cubed. Now 2 times 2 is 4, 3 take away 4 is negative 1, negative 1 cubed is negative 1, and negative 1 times negative 8 is positive 8. So the gradient is 8. Okay, let's work out what y is. Y is going to be 3 take away 2 times by 2 to the power of 4. So y is negative 1 to the power of 4. So y is 1. So the coordinates let's just make a note, the coordinates are 2, 1. Okay, so we've got y, we've got the gradient, we've got the coordinates, so we can do y, take away the y value, equals the gradient, lots of x, take away the x value, so y is going to be 8x, take away 16 plus 1, so y is 8x minus 15. There we have it. That is the equation of the tangent when x is 2. Okay, so here we've got some other examples of the chain rule. So this is mentioned towards the end of chapter 9c. So why can't we differentiate this? Well, it's a bit confusing because normally all the other ones we've seen has been y equals some stuff, and we've done dy by dx. Now if x equals some stuff, instead of doing dy by dx, we're going to do dx by dy. Okay, so if we've got x equals all this stuff here, then dx by dy is going to be 3y squared plus 4y. So if dx over dy is this, then dy over dx is just flip this stuff. Remember, this stuff here could be written as over 1. So therefore, if we're flipping the dx by dy to get dy by dx, then we can just flip this fraction to get 1 over 3y squared plus 4y. There we go, that is the derivative. Let's do another example here. So dx by dy equals e to the y, take away 7. So therefore dy by dx is just 1 over e to the power of y, take away 7. If x is the cos of y, then dx by dy, remember that cos differentiates to minus sign, so therefore dy by dx is just that flipped, so that's going to be minus 1 over the sine of y. Another way we could write this, remember if it's sine as a denominator, then that could be written as minus cosec y. Okay, with this next example, first of all, let's make it x not 2x, so x is 3 over 2y squared plus 1/2 the ln of y squared. So therefore dx by dy is going to be 3 over 2 times by 2, so that's going to be 3y plus 1/2. So we're differentiating the ln of y squared, so that's going to be a half times 2y on the top and a y squared on the bottom, so these y's can cancel out. So let me just take this up here. So that's going to be, so dx by dy, that is 3y plus 1 over y. So let's add these fractions together. So that's going to be 3y squared plus 1 over y. And if that is dx over dy, then dy over dx is just that flipped, which is y over 3y squared even, plus 1. There we go. Okay, so here are some trickier ones that we're going to apply the chain rule to. So we've got y equals sine squared 5x. Now, this whole sine squared thing does confuse people, so we need to remember that this can be written as it's the sine of 5x squared. So therefore dy by dx, just use the chain rule, power comes down to the front, reduce the power by 1, multiplied by the derivative, which is 5 cos 5x. So therefore dy by dx is going to be 10 cos 5x multiplied by sine 5x. Brackets don't really do anything useful there. Remember cos squared 4x, that can be written as y is the cos of 4x squared. So therefore dy by dx is power comes down to the front, cos of 4x to the power of 1 multiplied by the derivative of the cos of 4x. So remember cos goes to negative sign, so that's minus sine x times 4, so minus 4 sine 4x. So therefore dy by dx is negative 8 sine 4x multiplied by the cos of 4x. Okay, y is e to the power of 3x squared, so therefore dy by dx is e to the power of 3x squared multiplied by the derivative of 3x squared, which is 6x. So we can simply write that as 6x e to the power of 3x squared. Okay, so I'm not the e function was probably one we could have done before anyway. And again, and how you write it is entirely up to you. It's perfectly acceptable to write it like this if this is how you want to use your formula. You don't need to just stuff it all together. But well, obviously these two things are the same. Okay, to finish off with, here are two slightly tricky examples. So here we've got y is the ln of sine squared x. So we just need to remember that that is the same as ln of the sine of x squared. And when we're differentiating a ln function, it's the derivative of the stuff. So this is the stuff. The stuff is sine of x squared over the stuff. Okay, so differentiate the stuff over the stuff. So dy by dx, so first of all the denominator is going to be the sine of x squared, and the numerator is going to be the derivative of this stuff here. So power comes down to the front, reduce the power by 1, and multiply by the derivative of what's in the bracket here, so that's going to be cos x. Now we can see that on the top we've got a sine x cos x, on the bottom we've got sine x squared, so that is a sine x and another sine x, and of course one sine x will cancel top and bottom. So what we've got is 2 cos x over sine x, and maybe you know that, well hopefully you know that sine over cos is tan, and cos over sine is cot, so that is 2 cot x. Okay, for the second example, we've got this horrible stuff as a denominator, but we can write that as y is the sine of 2x minus 5 to the power of minus 1. So therefore dy by dx is going to be, power comes down to the front, minus 1, so that is minus 1 lots of sine of 2x minus 5, reduce the power by 1, multiplied by the derivative of the sine of 2x, take 5, well the derivative of minus 5, well, we can just forget about that. The derivative of the sine of 2x is 2 cos 2x. So we can tidy this up. That can become minus 2 cos 2x sine 2x minus 5 to the power of minus 2. Or we could write it, it's up to us how we write it really. We've got minus 2 cos 2x on top, and on the bottom we've got the sine of 2x minus 5. We need to be careful here actually, that looks like I'm signing 2x minus 5, it's just the sine of 2x, and once we've signed x times 2 then we're going to take away 5, so just sometimes the brackets are really important there. So a couple of ways we could write it. You can write it whatever way makes the most sense to you basically.